In this tutorial, I am going to show you how to make Pong, a simple but very addictive game where the player controls the right paddle and the computer the left one. We are going to build this game using C++ and the Raylib library. At first, we are going to build a simple black and white version, just like the original Pong of 1973. But at the end of the video, we are going to add colors to it to make it look better. Although Pong is a very simple game, it covers a lot of the aspects of computer game programming, like movement, controls, collision detection, scoring, artificial intelligence, and so on. If you learn how to program Pong, you will be able to program a lot of other games as well. In order to be able to follow this tutorial, I expect you to have a basic knowledge of the C++ programming language and a development environment for C++ already installed. I am going to work with Visual Studio Code. Lastly, we are going to need the Raylib library. I have prepared a detailed video on how to install Raylib on your Windows computer and use it with Visual Studio Code. You can watch it here. It will help you set up everything on your Windows computer. If you use a different operating system, you can still follow this tutorial if you have a working C++ setup with the Raylib library. So, if you have set up everything and you can compile and run a simple Raylib example program, we are ready to go. Our goal today is to develop Pong. It sounds very daunting, but don't worry. In programming, we use a technique called divide and conquer, which means that we break a complex problem into smaller, more manageable pieces. Then we solve each piece individually and put all the pieces back together to form the complete solution. So that's what we're going to do. We're going to break Pong down into smaller pieces and then write code to solve each piece. Here is a list of the pieces we need to solve in order to create the simple black and white version of the game. Create a blank screen and the game loop. Draw the paddles and the ball. Move the ball around. Check for a collision with all edges. Move the player's paddle. Move the CPU paddle with artificial intelligence. Check for a collision with the paddles. And add scoring. Now that we know what we need to do, let's get started. The first step is to create a blank screen and the game loop. First of all, let's talk about the game structure. Every game consists of two parts. The part where we define our variables and our game objects like the player paddle, the ball, etc. The other part is the game loop, which is responsible for updating the positions of the game objects and checking for collisions. The game loop is like the heartbeat of the game. The game loop runs over and over again until we close the game. So in each iteration of the game loop, we have to draw the game objects in their new positions and check if there were any collisions. This happens so fast that we perceive it as continuous movement. Now let's create a blank screen and the game loop. Let's open the C++ starter template for Raylib that I have created with VS Code. You can download this template project by visiting this GitHub repository. If you compile and run this project, it displays a bouncing ball example, which is part of the game we are developing today. But we are going to write everything from scratch, so in the main.cpp file, remove everything, just leave the return statement. Let's print something to the console to see that our setup is working. Cout, starting the game, end line. If we compile and run the game by pressing F5 at the terminal, we can see the message printed. Our setup works. Now let's create a blank screen for our game and the game loop. The first thing we have to do is to call the initWindow function. This function initializes a window and takes three arguments: the width and the height of the window and the title. For the title, let's enter my Pong game. And for the width and the height, let's create two variables to pass into the function. Constant int screen width is equal to 1280. Constant int screen height is equal to 800. With the const keyword, we declare these variables as constant because we won't change their values. So in the init window function, now we have just to pass these variables as the first two arguments. Our window is ready. Now, every time we create a window, at some point we have to destroy it, and we do so with the close window function. So, let's add the close window function here, before the return statement. The basic setup of the game is ready. Let's now work on the game loop. The game loop consists of three parts. First, we have to check for any events. Events are things that happen in the game that we need to respond to, like quitting the game, moving the paddle, etc. Then we have to update the positions of all the game objects. And lastly, we have to draw all the game objects in their new positions. We start the game loop with a while loop, like this. While, parentheses, curly brackets. The while loop will run over and over again until we close the game. The first thing we do inside the while loop is to check for any events. Now inside the parentheses, we type the condition. Window should close, parentheses, equals false. The window should close function is a very useful function. It checks if the escape key on the keyboard is pressed or if the close icon of the window is pressed, and returns true if that is the case. So if it returns true, the game loop ends and the window is destroyed. Our game loop needs two more functions. First, we need to call the begin drawing function. This function creates a blank canvas so we can draw our game objects on. Next, we need to call the end drawing function, which ends the canvas drawing. Lastly, there is something else we need to do. We have to define how fast the game should run. We do so by calling the setTargetFPS function before the game loop. The setTargetFPS function takes an integer as an argument, and that integer is the number of frames per second that we want. I am going to use 60 frames per second. So, setTargetFPS parentheses 60. That's it. If we don't define a frame rate for our game, the computer will try to run the game as fast as it can. So the game speed will depend on the speed of the computer. By defining a frame rate, we make sure that the game runs at the same speed on every computer. For this game, we define that we want to run this while loop and update the display 60 times per second. Now that the game loop is complete, we can run the game for the first time. If we run the game at this point, we won't see anything inside the game window, because we haven't drawn anything yet. But the important thing is that we can see the game window with the title and the dimensions we defined, and that we can reliably close the game, either by clicking on this X icon here or by pressing the escape button on the keyboard. Cool! We just completed a very basic game loop, so we can remove step number 1 from our list. We have made progress. The second step in creating our Pong game is to draw the paddles and the ball. First of all, let's see how to draw things on the screen. Raylib offers functions to draw all the basic shapes, rectangles, circles, lines, polygons, etc. Each of these functions take a number of arguments, and in each of them we have to tell the function where we want it to draw the shape on the screen. For example, let's see how to draw a circle. We need to use the drawCircle function, which takes 4 arguments. The first two are the x position and the y position of the center of the circle. The third one is the radius of the circle in pixels, and the last argument is the color of the circle. Now let's talk about the x position and the y position. The origin of the blank window we have created is the top left corner of it. So this point right here has x position 0 and y position 0. The x position increases as we move from left to right, and the y position increases as we move from the top to the bottom. So what are the x and y coordinates of the center of the window, given that our window is 1280 by 800 pixels? It is 640 by 400. It is the window width divided by 2 and the window height divided by 2. Okay, let's call the function to draw a ball in the middle of the screen. Inside the game loop, after the begin drawing function, we type draw circle. Since the ball needs to be in the center of the screen, we need to just enter the coordinates of the center of the screen here. Screen width divided by 2, comma, screen height divided 2. Next is the radius of the ball. So let's say it's 20 pixels. And then the color of the ball, white, in capitals. Raylib offers many predefined colors. We use them for now and we're going to learn how to create our own colors later on. We are ready to test our code. As you can see, a white ball appears in the middle of the screen. Our first game object is visible. Now let's create the two paddles. Since the paddles have a rectangular shape, we are going to use the drawRectangle function. Again, this function requires the x and y positions where the rectangle is going to be drawn, a width and a height, and a color. There is a minor difference though. The rectangle is drawn from its top left corner. For example, let's create a white rectangle with a width of 25 pixels and a height of 120 pixels and place it at 0, 0 at the top left corner of the screen. Draw rectangle 0, 0, 25, 120, white. Okay, if we run the game, the paddle is placed at the top left corner of the window. But what if we wanted to place it at the center of the screen vertically? Well, our first thought will be to change its X position and make it screen height divided by 2. Is that correct? Let's see. As you can see, the paddle is not centered correctly. As we said, the rectangle is drawn from its top left point. Now we centered its top left point vertically. We want this point to be centered vertically. What is the y coordinate of this point? It is screen height divided by 2 plus rectangle height divided by 2. So if we make y position is equal to screen height divided by 2 minus rectangle height divided by 2, our paddle will be centered vertically. So we change the draw rectangle like this, 0, screen height divided by 2 minus 60. Let's run it and see if it is centered. Cool, as you can see, the paddle is now centered vertically. Let's move its X position 10 pixels to the right to look better. We just type 10 here for the X position of the rectangle. Great, the first paddle is ready. To create the second paddle, we just have to copy this line of code and change the X position of the new rectangle we're going to create. What is the X position going to be? We need it to be at the end of the window and 35 pixels to the left. Why 35? As we said, the rectangle is drawn from its top left corner, so the top left corner has an X coordinate, screen width minus the rectangle width, which is 25 pixels, minus 10 pixels, because we want a 10 pixel offset from the end of the screen. That's it. If we run the game, we can see the ball and the paddles at their correct positions. Now, let's draw a line that separates the two sides. This one is easy. We just need to call the drawLine function in the game loop. It takes 5 arguments. The first 2 are the coordinates of the starting point of the line. The next 2 are the coordinates of the ending point of the line. And lastly, we need to pass in the color of the line. The starting point is going to be this point, which has coordinates screen width divided by 2, 0, and the ending point is this one, which has coordinates screen width divided by 2, screen height. So in the game loop, before the other element, we type drawLine screen width divided by 2, 0, screen width divided by 2, screen height, white. If we run the game, we can see the line as well. Cool, our game elements are ready. Step number 2 is now complete. Now, let's animate all the elements. So far, we have created 3 game objects, the ball and the 2 paddles, and we have moved them to the correct position on the screen. And in the game loop, we draw them at the same position 60 times per second. If we want to animate these game objects, all we have to do is to move their position a little bit at each execution of the game loop. Since we update the screen 60 times per second, this tiny movement is perceived as continuous movement. First, let's animate the ball. In order to make our lives easier, we are going to create a ball class and give it some attributes and some methods. So we type class ball, curly brackets, and a semicolon. Let's give the ball some attributes and let's make them public. We must know the x and y coordinates of the ball, so let's declare them here, float x, y. Next, we need to know the speed of the ball in the x and y axis. So let's create two more attributes, int speed x, speed y. Lastly, let's give the ball a radius, so the code is more flexible, int radius. Now, so far we only draw the ball on the screen. Let's move this function, which draws the ball on the screen, inside the ball object, where it belongs. Void draw, curly brackets. Now here, we just have to draw the circle at its x and y position, so we change the call like this. Draw circle, parenthesis, x, y, radius, white. Our class is ready. Let's create an instance of it. Ball. And inside the main function, let's initialize the ball object. Let's give it a radius of 20 pixels. As we said before, the ball must be in the center of the screen. So ball x is equal to screen width divided by 2, and ball y is equal to screen height divided by 2. Next, let's give the ball a speed of 7 for the x direction and a speed of 7 for the y direction. Our ball object is ready. Let's draw it. Inside the game loop, we simply have to call the draw method of the ball object. Ball.draw. Now we need to make the ball move. Let's create an update method to the ball object. Void update, curly brackets. Now to make the ball move, we just have to add the speed x variable to the x position of the ball and the speed y variable to the y position of the ball. These two lines of code increase the x and y coordinates of the ball object by 7 pixels each time the game loop is run. Let's call this method in the game loop. Before the drawing part of the game loop, we just call ball.update. Let's run the game to see what happens. As you can see, it almost works. The ball moves. But we have two problems to fix. The first problem is that the ball leaves a trace of its previous position. We can fix that easily with just one line of code. But first, let's talk about how the game loop draws the elements on the screen. In every game loop, our game executes these commands one after another. First, it draws the line, then the ball, and then the paddles. It does that 60 times per second. Each time it draws something on the screen, it does not erase what was drawn before. That's why the ball leaves a trace when it moves. So all we have to do is to clear the screen in every game loop before drawing the game objects in their new positions. So before drawing the object, we simply have to type clear background, parenthesis, black. With this function call, we tell the computer to fill the window we are drawing with black color, and this way we are clearing it. As you can see, if we run the game once more, now the ball does not leave a trace, so the animation works as expected. So we have completed step number 3 as well. That was fast, wasn't it? The second problem we have to fix is that the ball moves out of the game window. This is step number 4, and we are going to work on it at once. Let's think about the problem we have to solve. The ball leaves the game window from the bottom when we run the game for the first time. Let's make the ball bounce when it hits the bottom of the screen. The ball object has an x and y position attribute, which is at the center of the ball. So we have to check if the bottom point of the ball is greater or equal to the screen height. If it is, we have to make it change its direction in the y-axis. But the y-coordinate of the bottom point of the ball is not the same with the y-coordinate of the center of the ball. The bottom point y-coordinate is ball y plus radius. Be careful here. So let's write code for this. In the update method of the ball class, we add if y plus radius greater than or equal to. Now we need the window height, but we have declared it inside the main function. We can make it a global variable, but we can also call the getScreenHeight function of the Raylib library, which returns that value. So we add getScreenHeight. Now we have to reverse the speed on the y-axis. We simply type speed y asterisk equal -1. We have to do the same thing for the top of the screen. So in the if statement we add or y minus radius, this time less than or equal to 0. With the same technique we can check for collisions at the left and the right side of the game window. If x plus radius greater than or equal to getScreenWidth or x minus radius less than or equal to 0, now we have to change the direction of the ball in the horizontal axis. So we have to change the speed x variable. Speed x asterisk equals -1. And with that, we just completed step number 4. As you can see, when we run the game, the ball bounces around inside the game window. Cool, huh? Our game has just come alive. One thing I have to point out is that in the if statement here, we don't compare if the two values are equal with the double equals sign. If the ball moved 1 pixel per time, the equality will work. At some point the ball will hit exactly the end of the window. Since we are moving the ball by 7 pixels per frame, the ball will not always hit the exact end of the window. So we check if the ball moved beyond the end of the window and then we reverse its speed. Now let's work on step number 5. Let's make the player paddle, the right one, move up when the player presses the up arrow key and move down when the player presses the down arrow key on his keyboard. First of all, let's create a paddle class and give it some attributes and some methods. So we have to type class paddle, curly brackets, and a semicolon. Each paddle has an X and Y position. That's the top left corner of the paddle. Additionally, we must know the width and the height of the paddle. Also, it can move, so it must have a speed. But it can only move in the y-axis, so we only need one speed attribute. Let's add the attributes to the class. Float x, width. Float width, height. Int speed. Now let's create the draw method of the paddle class, which will be responsible for drawing the paddle on the screen. We get this line from the game loop and we paste it in the draw method. We modify this line of code like this. Draw rectangle, parenthesis, x, y, width, height, weight. We just draw a white rectangle at a specific point on the screen. Now let's create a paddle object and let's name it player. Paddle player. In the main function, let's initialize it. Player.width is equal to 25. Player.height is equal to 120. Player.x is equal to screen width minus player width minus 10. Player y is equal to screen height divided by 2 minus player height divided by 2. And let's set the player speed as well. Player speed is equal to 6. Lastly, we have to call the draw method of the player object in the game loop, just like this. Let's test our code. As you can see, the modified code works and we can see the player paddle at its correct position, but it is standing still. Let's animate it. So let's create an update method in the paddle class. Void update, curly brackets. We want to move the paddle up when the user presses the up key on his keyboard. Raylib makes it very easy to detect when the user presses a key on the keyboard with the isKeyDown function, which takes a key constant as an input. So to check if the user has pressed the up key on his keyboard, all we have to do is to type if isKeyDown, parenthesis, key up. That's it. Now we can just add some speed to the Y position and we are done. y is equal to y minus speed. We subtract the speed from the y position because we want to move the paddle up, and since the origin of our screen is at the top left, if we want to move upward, we need to decrease the y coordinate. We can do the same thing if the user presses the down key on his keyboard. If is key down, parenthesis, key down, curly brackets, y is equal to y plus speed. The last thing we have to do before trying our game once more is to call the update method of the player object in the game loop. So under the ball update line we type player.update. Let's now try our game. Great! I can move the player paddle up and down and it stops when I release the buttons. But there is a problem with our code. The paddle can move outside of the screen. We have to fix it before moving on. The fix is easy. All we have to do is to make a change in the update method of the paddle object. We are drawing the paddle rectangle from its top left corner. So when the paddle moves outside of the game window, we have to move it back in. So let's check if it has moved outside of the top window. If y less than or equal to 0, curly brackets, let's move it back in, y is equal to 0. We do the same thing for the bottom of the screen. If y, but now we have to add the height of the paddle, plus height greater than or equal to getScreenHeight. Now we have to move it back in the window. Y is equal to getScreenHeight minus height. Remember, we need to remove the height of the rectangle from the screen height because we are drawing the rectangle from its top left point. Let's now test the game to see if it works as expected. As you can see, we can move the paddle up and down and its movement is restricted inside the game window. Beautiful! We have just completed another step. Let's cross it out from our list. Now, let's make the computer move the paddle, which is the next step in the list. The CPU-controlled paddle is a paddle which is identical to the player paddle, with a minor difference. It is controlled by the computer. So, we won't create a new class from scratch for the CPU paddle, but instead, we are going to use what in object-oriented programming is called inheritance. This way, we are going to type less code and practice our object-oriented skills. We are going to create a CPU paddle class that inherits from the paddle class, which means that the CPU paddle class has all the attributes and the methods of the paddle class. Let's create the CPU paddle class now. Class CPU paddle, curly brackets. Now let's make this class a child of the paddle class. We type :public paddle here. Now, the CPU paddle class has all the attributes and the methods of the paddle class. So let's create a CPU paddle and draw it on the screen. First, let's create the object, CPU paddle CPU. Now let's initialize it. CPU height is equal to 120, CPU width is equal to 25, CPU X is equal to 10, CPU Y is equal to screen height divided by 2, minus CPU height divided by 2, and CPU speed is equal to 6. Now let's call the draw method of the CPU object in the game loop here, CPU.draw. And then we have to remove the draw rectangle function we have here. If we run the game now, we can see that the CPU paddle is drawn correctly. At this point, the CPU paddle inherits the update method of the paddle class. But we need a different one, because we want the computer to move the paddle and not the player. So we have to override the update method of the paddle class. We will provide a different update method for the CPU paddle class. Let's do it. Inside the CPU paddle class, we type public void update, curly brackets. Now it is finally the time to move the CPU paddle. For this, we are going to use a very basic but effective artificial intelligence algorithm. All we have to do is to check if the Y position of the ball, which is in its center, is above the Y position of the center of the paddle. If it is, we move the paddle up. If it is not, we move the paddle down. So in the update function of the CPU paddle class, we type if Y plus height divided by 2 Greater than, that's the y coordinate of the center of the paddle. Now we need the y position of the ball. Let's get it as an argument, ball y. So we have to declare it here, int ball y. So if the center of the ball is greater than the center of the paddle, we need to move the paddle up. So we subtract the speed from the y coordinate of the paddle. Y is equal y minus speed. Now let's check if the ball center y is less than the center y of the paddle. If y plus height divided by 2 less than or equal to ball y is equal to y plus speed. Okay, our basic algorithm is ready. Let's call the update method in the game loop and give it the ball height value as an argument because it needs it. Let's run the code to see if it works. As you can see, the CPU paddle is moving by itself and it follows the trajectory of the ball. It does not move outside of the game window, but it is a good idea to enter some limitation to its movement, as we did with the player paddle. So we just have to copy and paste this block of code from the paddle class to the CPU paddle class. But copying blocks of code around is not a good programming practice. We can use object-oriented programming to our advantage. Instead of copying this block of code, we are going to create a method from it that will be inherited by the CPU paddle as well. This method is going to be protected. No other part of the program should know about it. So we type protected, void limit movement, curly brackets, and inside it we paste the code that limits the movement of the paddle. Now, inside the CPU paddle class, inside the update method, we just have to call the limit movement method and we are done. The CPU paddle class inherits the limit movement method from the paddle class, so we don't have to rewrite it. With this small change, we avoided duplicate code inside our program. Cool. If we now run the game once more, we can see that the game works as expected so far. We can move the player paddle and the computer can control its own paddle. Another step is now complete. Now we need a way to detect if the ball collides with the paddles. Luckily for us, the Raylib library makes collision detection extremely easy. There is a function called checkCollisionCircleRec, which checks if a circle collides with a rectangle. It is exactly what we need. We need to check if the ball, a circle, is colliding with a rectangle, a paddle. Let's use it. In the game loop, we write if checkCollisionCircleRec. Now this function requires some arguments: the circle center, the circle radius, and the rectangle to check for collision. The first argument is of type vector2, so we type vector2 curly brackets, and we just pass the x and y coordinates of our ball object, so ball x, ball y. The radius is just the ball radius. The last argument is the rectangle we want to check for collisions. It is of type rectangle. So we need to give it the top left corner coordinates of a rectangle and the width and the height of that rectangle. Let's check for a collision with the player paddle. All we have to type is rectangle, curly brackets, player.x, player.y, player.width, and player.height. If the function returns true, we have a collision with the paddle, so we have to reverse the speed of the ball in the x direction. We just type ball.speedx asterisk equals -1. We do the same thing for the CPU paddle as well. If checkCollisionCircleRectangle, parenthesis, vector2, curly brackets, ball x, ball y, ball radius, rectangle, curly brackets, CPU x, CPU y, CPU width, CPU height, ball speed x asterisk equals -1. Believe it or not, our collisions are ready. Let's check our game. As you can see, the collisions work fine. If the ball hits on a paddle, it changes its direction. Another step is now complete. Let's move on to the last step we have to complete. Let's add scoring to the game. First of all, let's create two global variables for the player score and the CPU score. Before the ball class, on the top of the file, we type int player score is equal to 0, and int CPU score is equal to 0. Now we have to check whether the player or the CPU wins a point. The CPU wins a point when the ball hits the end of the screen here, and the player wins a point when the ball hits the other end. So inside the ball class, in the update function, we have to make some adjustments to the code. We have to break this if statement into two parts. X plus radius greater than or equal to get screen width. The CPU wins a point when this happens. So let's increase the CPU score. CPU score plus plus. Then we have to check if the player wins. If x minus radius less than or equal to 0, player score plus plus. Cool. Now we can display the points on the screen. We are going to use the default font the Raylib library offers. With the default font, displaying text on the screen is very easy. We just have to call the drawText function. First, we're going to display the CPU score. Let's call the drawText function inside the game loop, where we draw all the game objects on the screen. drawText. Now we need to provide the function the following information: the text we want to draw, the X and Y position where we want the text to be drawn, the font size and the color. The color is easy, white. The font size is also easy. A value around 80 works fine. For the position X and position Y for the CPU score, let's put 20 pixels from the top of the screen for the position Y. And let's say screen width divided by 4 minus 20 for the X position. Now we want a text to print for the CPU score. We just want to print the CPU score, which is an int number, CPU score. So we have to convert it to text. Raylib has a function for that, text format. Text format parentheses, quotes, %i, CPU score. Our function is ready. We do the same for the player score. We just copy and paste this line of code. We change this to player score and change the X position location to be closer to the player paddle. That's it. Let's try it. As you can see, the score appears on the screen. If we let the computer win, we can see that the ball disappears and the CPU score keeps increasing. We are not resetting the ball when someone scores, so it moves out of the game window. That's something we have to fix. It is easy, don't worry. Let's create a new method in the ball object and name it resetBall. We need to return the ball to the center of the screen. This is easy. X is equal to getScreenWidth divided by 2 and Y is equal to getScreenHeight divided by 2. We also need to give it a random direction in both the X and Y axis. We are going to use the getRandomValue function of the Raylib library. We are going to multiply speedX and speedY values with either 1 or -1 randomly. So let's create a list of just two values, -1 and 1. Int speed choices brackets 2 is equal to curly brackets -1, 1. Now let's multiply speedX by a randomly selected item of this list. SpeedX asterisk equals speed choices brackets getRandomValue 0, 1. We do the same thing for the speedX variable. SpeedX asterisk equals speed choices brackets getRandomValue parentheses 0, 1. Just like that, we randomize the speed of the ball. Our game is almost ready. Let's call the resetBall method when each player scores a point. ResetBall here and here. We can test it out and see that it is working great. Of course, there are a lot of things we can improve on this game. We built the most basic version of the Bonk game possible to learn how to work with C++ and the Raylib library. Before completing the video, let's add some color to the game to make it look better. Let's make it look like this. We need to use 4 colors to achieve this appearance. Let's create them. For this, we are going to declare them as global variables of type color. Color green is equal to color curly brackets. And now we have to enter the RGB values of the color, plus the alpha channel, which is transparency. We don't use transparency, so this value will be set to 255. For the green color, the values are the following: 38 for the red, 185 for the green, and 154 for the blue color. Great. Now with the same procedure we create the next three colors: dark green, light green and yellow. Our colors are ready. Now let's start with the easy one. Let's make the ball yellow. We go to the draw method of the ball class and we change the color of the ball from white to yellow. Next, let's change the background color of the window to dark green. We go to the main loop and in the function clear background, we change the color from black to dark green. Let's run the game with these two changes. As you can see, the game looks so much better with just two small changes. Let's now draw the player half of the screen with green color. For that, we just have to draw a rectangle on top of the dark green background. So after the clear background call, we type draw rectangle green. Now we have to define a rectangle which is half the game window. Screen width divided by 2, 0, screen width divided by 2, screen height. Cool. Let's now draw a light green circle on top of all that from the center of the screen. That's very easy. Draw circle, parenthesis, screen width divided by 2, screen height divided by 2, 150, light green. Beautiful. The game looks way better in my opinion. One last thing I want to change is to make the paddles have rounded edges. For this we're going to change the draw method of the paddle class. Raylib offers the draw rectangle rounded function which draws rounded rectangles. It needs a rectangle, a roundness value, a segment value and a color. The color is white. Segment variable is 0. 0.8 for roundness works great. And lastly we need a rectangle to draw. We just enter the x, y, width and height attributes of the paddle class and we are ready. Since the CPU paddle inherits from the paddle class, it will appear rounded as well. Let's run the code to see how it looks now. Awesome! Our game looks great and it works as expected. With just a few changes, we made our game way more pleasing aesthetically. I hope you like it. It was a fun project. I really enjoyed it. As always, you can find the full code of this tutorial in the video description. I hope this tutorial was useful and that you learned the basics of Raylib. If you like the video, please give it a thumbs up and consider subscribing to the channel if you don't want to miss my future tutorials. Thanks for watching, I'll see you next time.